Hi, I'm Raz, and today we'll be looking at parametric differentiation. So I'm just going to do worked examples for this video. We will be using the chain rule a lot, which is this. If you don't know the chain rule, watch my chain rule video. So we have the chain rule is dy by dx equals dy by dt times dt by dx. And we have x equals 3t squared, so it follows that dx by dt is 6t. We're also given that y equals 1 minus t cubed. So if we differentiate y with respect to t, we will get minus 3t squared. So if we use the chain rule here, we know dy by dt is minus 3t squared, but we have dx by dt where we need dt by dx. You just have to realize that there's a reciprocal relationship. Yeah, so that means dx by dt is equal to 1 over dt by dx. So it's a reciprocal relationship. So we just find the reciprocal of 6t. So the gradient function dy by dx will be dy by dt minus 3t squared times by the reciprocal of 6t, which is dt by dx, which is 1 over 6t, which will simplify to minus 3t squared over 6t. Clearly, we can cancel that down, and we'll get minus t over 2. So that would be the gradient function there. Let's do the second example. So x equals t cubed, therefore dx by dt will be 3t squared. Y equals 3 over t, which is 3t to the power minus 1. So when we differentiate that, we will get dy by dt will be negative 3 t to the power minus 2, which is the same as negative 3 over t squared. So if I write the chain rule, dy by dx equals dy by dt times dt by dx. So dy by dt is minus 3 over t squared. dt by dx is the reciprocal of 3t squared. So dy by dx is minus 3 over t squared times 1 over 3t squared, which will be minus 1 over t to the power 4. Example 3. We have x is the square root of t. Let's put that in index form first, t to the power half. Therefore, dx by dt will be a half t to the power minus a half, which is 1 over 2t to the half. And y is t squared minus 7, so dy by dt is 2t. Chain rule, dy by dx equals dy by dt times dt by dx. dy by dt is 2t. dt by dx is the reciprocal of this, which is 2t to the half. Yeah, that is definitely correct. So dy by dx is 2t times 2t to the half. Now remember, 2t is 2 to the power 1. So it's 2t to the power 1. So we end up with 4t to the power of 3 over 2. Job done. So now let's apply this to a question. So here we are given a parametric function and we are asked to find the equation of the tangent given a particular parameter. So as we did before, first we differentiate parametrically. So if x equals t, it will follow that dx by dt equals 1. Therefore, dt by dx is also equal to 1. And if y is t cubed, dy by dt will be 3t squared. Yeah, so the chain rule is dy by dx equals dy by dt times dt by dx. So I've got 3t squared times by 1. So dy by dx equals 3t squared. But we're given the parameter t equals 2. So I can figure out the gradient of tangent. So m1 will be 3 times 2 squared. So 12. If we had been asked the gradient of the normal, we would do the negative reciprocal of that. And then we would proceed from there. But we weren't, so I'll just stick with this. So y equals 12x plus c. Oh, I don't have a coordinate. What do I do? Oh yeah, I'm given t equals 2. So we just sub that in here to figure out the value of x. So we can see x equals t. So t is 2, so x must be 2. And y equals t cubed, and 2 cubed is 8. So those would be the coordinates when t is 2. The coordinates would be, so at t equals 2, x will be 2 and y will be 8. So that is our coordinate. So we can now finish it off. So 8 equals 24 plus c. So c equals 8 minus 24 minus 16. Therefore, y equals 12x minus 16. So that completes the video. So what we've seen is how to differentiate parametrically and an application of it on this last example. I hope you enjoyed the video. See you soon.